So we've looked at the rate of reaction. I'll put some videos up on how we measure it. So it can be colour change, it could be some gas being evolved, it could be just a change of state. There's lots of different ways. The iodine clock one is a really good one because it just goes, clicks really quickly over and goes from one colour to another and then back again. So it's a really good one for looking at a really quick rate of reaction. So we've looked at the rate. Yeah, that's fine. It happens, something goes, but what are we actually going to do with it? So we need to think about collision theory. So we need to think about these little particles, either atoms or molecules or whatever they are, kind of roaming around, and we're trying to put them together and get them to do something with each other. So what we need to think about is why they're going to work, why they're going to collide and become what we want them to. So we want the reactant normally, because that's the point of doing it. We want the reactant, so how are we going to make it so we get as much of that as possible? So that's the overarching idea of it. How do we get that product in the easiest way, the cheapest way, and the most of it? Because, you know, if I'm making aspirin or whatever, I don't want to be paying loads of money and not getting much. I want to do it as quickly, cheaply, easily, and making that thing. So what we need to do is we need to make these things, the reactants coming together. So what we need them to do is they need to come together. They mustn't collide. So we've got A and B. We've got Beeker and Bunsen. I can't remember which one's which. Anyway, we've got them. And what they're going to do is they're going to react. So these are our reactants, A and B, and our product is them stuck together in a synthesis. So synthesis is when we're sticking things together. So we're going from this, two things, to them being stuck together. So how are we going to do it? So we've got loads and loads of them. Imagine there's like billions and billions, moles and moles, however many we've got. Right, they're all floating around. So what they must do is they must collide with each other. They can't just one over here and one over here. Then nothing's going to happen. So they must collide. And they must collide with enough energy. So remember our activation energy graphs, those ones that go up and down. You've got the two types. But remember when we did that and you had your little EA, activation energy, and then it goes down. And you can remember our delta H. And then you've got the other one that goes up and down again like that. So the exothermic goes down and the endothermic going up like that. Bit of a while ago, but it's in there somewhere in your brain. Right. So we've got our little molecules. Right. They must have enough energy. So if they're just wandering around and they don't have enough energy to collide, they're not going to do anything. So we need to give them a kick of some energy. It needs to have enough energy to go over that activation energy bump. Oops, if I don't waver. The activation energy bump, so they can combine, so they can be synthesized together. So they've got to have enough energy, and we can think about some ways we can increase the energy into our system. So we've got them, lots and lots of them roaming around. So they must collide. They must collide with enough energy, and they must collide in the correct way. So going to be maybe a bit inappropriate, but they have to collide this way, right? And now they're stuck together forever until we maybe break them apart. But stuck together, now they're done. But if they come this way, yeah, they're not going to stick. It's not going to work. So they've got to be in the right orientation. And this is going to be really tricky when we think about our more complicated organic molecules, because there is really this handedness and chirality and all this complicated stuff. But they've got to hit in the right way. They can't just, yeah, whatever, that's kind of close, that would do nearly. It's not going to work. So they've got to be colliding in the correct orientation. So, little molecules, our reactants making a product, wandering around, and they've got three things. So they've got to collide with enough energy to overcome our activation energy, and they've got to do it in the right way. Right, the second point.